Hi there! Again, a new update for the new version of the Time Bomb game series. Yeah, I have here the old setup. You saw maybe in a previous video from a month ago or something. And I want to show you, the next development stage. And what I was busy currently a lot with was the communication via the CAN interface, or the CAN protocol actually. It uses a two-wire differential communication line, actually a bus, and you can attach multiple devices on the bus. And for this sake and this demonstration, I have only one device. So this thing here is the main module, like the main game Time Bomb, used in escape room or for somewhere else you can use it. And this one is like an external module you can put somewhere else. You can maybe add something that you need to solve. You can add a timer on it. You can do actually anything with these things, and a lot of different functions are there. I can't explain just now. For now, this thing only is for demonstration, showing a timer, and it has a button for demonstration. I can interact also with the main module. So let's just turn this thing on, and then we can go on with it. I'll show you what's happening. So I turn this one on. Yeah, let me turn on the light. Okay, now you can see the basic screen like you saw before maybe. Now with the keypad here down below, it's a little dark. I can start the timer. Now this timer starts, and you can see also the timer up there starts. So it's just a simple thing. You need to enter code, and when you enter the correct code, the bomb diffuse. Now, what's new there is also this little frantic little blimping thing up there. There's a CAN bus controller. It shows me that there's actually communication for debugging purposes. And what it does, it sends its data. I programmed this one to send its aware that it's there, you know, there's heartbeat every 1 second. And also when the timer is ticking down, it sends its timer data. And it just sends it over the CAN bus, and any node on it which want to use that information, like the timer, can pick it up. So I programmed this node, it's also connected via this wire on this CAN bus, and it can take, in this case, it takes timer from it, and then now it's synchronized with it. So what happens if I just turn a little light up there, so like that, and if I take the CAN bus off, if I can do that with one hand. Filming is really a thing, you know. I need an extra hand, camera setup or something, whatever. Now. Okay, if I take it off, you see timer hangs. Looks like it's hanging. The funny thing about it is you can just connect it. It doesn't matter anymore. Connect it again, and there it goes. Picks up again. Okay. What I also added was the audio files. I put some audio files. If you put a wrong code.
Validation has failed.
There you get this. You get a new voice modification, and if you voice, how you call it, it says to you what happens.
Phew, that slowed down timer will help for now.
So then you know if you have a good, well, actually helping code, you know, if you put that in there, then the timer slows down for a little while, and you get a friendly message that the timer slows down. And if you put a bad code like this, bad codes like you get really punishment, like a red herring or something. You shouldn't really use those in an escape room, but okay. It's there to be used.
Oh no, you are screwed now.
Then it says you're screwed. So there you go. And then it goes down faster for a longer time. And the correct code was just the same thing. Like the old serial number, but the serial number is not that anymore.
Disarming successful.
And that was it. So now you can see how this works. Now a little demonstration extra timer. It has this this thing. It's connected with the CAN bus. You can see the data coming there. Now the data is going slower because this timer is standing still. So it's aware that it's not really changing much. So the data throughput is a little lower to spare campus transmission. You see also there that it's a little less frantic. And that's it. I'm using the Teensy4.1 here, and this is an old Teensy 3.2. I really like these Teensy boards, they're really fast. This thing is running actually at 720 megahertz, overclocked a little bit, a little cooling on there, so it's warm to the touch, but it's okay. And this one is running 92 megahertz, it's fast enough, really fast. It's like just an Arduino on steroids or something. If you, and I'm using here this audio module. This is a I2S audio module. It's some, yeah, I don't know how it exactly works. I'm not really in the depth of it, but it uses the same kind of format as I2C, but then for audio. That changed the left-right clock and have a bit clock. It was really interesting. Yeah, that sounds okay. You have nice audio over there. I needed to use a really fast SD card because I playing multiple sounds after each other. Well, not after each other, simultaneously. And I can like four or something. So you have the background, and then when you have a bad code, I can show you now what I mean with that. So if there's a bad code, listen to what happens. So you hear now, let me put this a little bit up. Okay, you have a background now, but when I start the timer, you get a different background music, like the spy music, this free sample, I don't know, it's everywhere on YouTube. So, and when I do a bad code, let's do this, listen to the background.
Oh no, you are screwed now.
You hear that? You hear a different background. But what happens when I put a good code?
Phew, that's slowed
See,
down.
it goes back to the first background music. But it's not starting over. It's actually the first background music, the spy music, that slow thing that you're hearing now, is actually still playing. But the gain of its mixer is set to 0, so you don't hear it. And then the upbeat, the more tempo one, when you have a bad code and the time goes faster, that get played also. So there are actually 2 background files playing, but only one you hear. And the thing is, because this library I'm using for this audio, it have a difficult time to seek and pause because it's using a stream from my SD card, and yeah, to save the place, to save the position on the SD of the file on the SD card, and then use the same stream to seek it. It's really a pain in the ass. So I just use it like this. So it's playing 2 background sounds at the same time, and also this tick here, tick, tick, tick. And these things, the beeps, and just confirming, validation. Everything is playing simultaneously. So up to 5 things are playing simultaneously, and this SD card is really struggling with that. It's not the Teensy. The Teensy does it very well, like 720 megahertz. It drives the screen, it drives everything, CAN controller. It drives a lot, and also the audio. But the SD card, it needs to be really fast. So I use the SanDisk Extreme card for it, and even that it's pushing its limit sometimes. And it's really it's not really the throughput, yeah, maybe a little bit, but more the access time. And it needs to buffer a little bit of the audio file into a memory location of the. Oh, my English is really bad. In a memory, in some kind of memory buffer for to place seamlessly. You use interrupts for that. But the access time of the SD card is really important to that, and this has access time of about 2 to 3 milliseconds, and that's really just enough for playing all those files simultaneously, because it's putting a stream up from one file, and then it needs to switch back to another file, and it has an access time, but because it's also streaming something else, the access time is go lower. It's going back and forth from file to file in there. So it asking reading a lot from this SD card. It's not like you playing a simple video stream from one file, because then you can just read from a stream. You know, it doesn't really matter. Like it's 1080p or 4K, it doesn't really matter. It can pull it through. But it's a thing. It's simultaneously different files from different locations. It has to switch a lot, and these things have a little how you call it, some kind of small operation system on it or something. The controller in there. The SD card is not just storage; it's also a controller. It also handles how you call it, and the wear leveling and thing. It smooths out the place where you write things to make it lasting. There's really a lot going on in an SD card actually, and that's why it's sometimes a pain in the ass to use it. But if you, I'm using the fastest one I could find. This is the extreme one. Yeah, there's also faster, but way more expensive. And it just do fine. It is good. I don't have problems with it.
Validation has failed.
This video is going to take long, and I'm still looking on this SD card thing. I can show something I have put here. Oh yeah, I can put some comments in there, like I have a message system. Oh yeah, this button here, I can press it. This button is connected to this one. It's just a demonstration that if I press it, then it sends a CAN message back to here, and then you can see it. So this one is connected to this cable, like I said before. It uses the CAN protocol. I press it, and then I get a message. That's all. That's all. And so I press it, and it's sending its message to there. And I can also see it there when I press the button. Yeah, and I get an error here because the message buffer is full. That's this buffer here. I mean, you can see, you can press it, but it doesn't get more on there because I don't have more space. So I just used a fixed size buffer for these messages, and then I just get an error here because it's trying to put more in there than I need. And this message system is also new, I think. Okay, you can see there under there's a bar there dropping down. The message system is automatic. You can there, or you can cancel it by yourself, like this. And then on the start button you can see it. I need to really go out there. Filmmakers on my thing. Okay, so this, you press a message, and you can also delete it like this. I can also do a test message on the Friday computer. So I do the T, and if I press enter here, then I get a message with chickens. Yeah, I really like chickens. Chickens are nice animals. And you see that little bar there under the processing going down until the message disappears, or you can just delete it. So there's a little message system I put in there. It's like for hints or something, when there's an escape room and you want to give people a hint, then you can put a message up that says, hey, you have a new hint, and then it goes down away by itself, or they can just push one of these to get rid of it. And then I go to options, and oh, wrong one. And then in hints, they see show hints. They can see the available hints. And this is one I had there before for some reason. Oh yeah, it was for first test game or something, to show you number. And yeah, this menu is of course, yeah, doesn't work yet. Options, you can see device info. It's like a little thing, a little GUI in there. It really works well, I think. And that's nice. You can also use the serial interface for it. So if I like open the menu is star. So if I press a star in here and I press enter, see, then it's open the menu. So you can also use the keyboard for your UART, but I know it's just niche. Now this thing is going boom just now. I have a feeling I'm just talking a lot and not showing so much. You hear the beeps changing. See, everything goes overlapping also. The GUI really works well. I really like it. And that was boom. It's done. So that was it. Now, I hope you liked this video, and I didn't get annoyed by my bad English so much. I tried my best, and see you next time.